Our goal for this video is to take a look at how we can find the area of parallelograms and triangles and other shapes that are maybe combinations of these, rectangles, triangles, things that we know about. So to start off, I'm just going to give you a couple of formulas that you should know already if you're starting off. If you've been in a geometry class for a while, you should have seen these before. So the one on the left says the area of a rectangle. Just multiply the base times the height, right? Sometimes referred to as the length times the width, all right? And on the right-hand side, we have the area of a triangle. We say to take the length of the base, right? Multiply it by the height, which, remember, when we're talking about heights, they are always defined as a perpendicular line to the base, right? So that actually happens over here in the rectangle as well, right? We have a base, and then the height happens to be at a perpendicular because rectangles have perpendicular lines, right? So in a triangle that doesn't necessarily have perpendicular lines, when we measure the base, the height will always be a line that is perpendicular to that, right? So that's why we have the h going through the middle of the shape and not on one of the outsides. And you can see down here, 1/2 base times height is the formula, right? So what we're going to do is we're going to focus on things that are maybe not necessarily rectangles. So this is a parallelogram. And the nice thing about a parallelogram is it actually uses the exact same formula as a rectangle. So for parallelograms, we're going to say that the area is also the base times the height, right? So here's where the kind of things get a little bit different. When we're talking about the base and the height of a parallelogram, the base can actually be any of the sides. So in this particular example, right, when we're taking a look at the base and the height, we're actually going to say the base in this case is the 5. And the reason I'm going to use this is because coming out of that at a right angle is its height, right? So again, I can't use this 4.5 because it's a slanted line. It's not at a right angle. So I'm going to use the 5 and the 4 and just plug into the formula and say, in this case, that the area of this parallelogram is just 5 times 4, which is 20. And remember that when we talk about area, we use a unit of square inches squared, right? Which actually means that if I took 20 little 1-inch squares, 1 inch by 1 inch squares, I could exactly cover this space. That's what inches squared means, okay? So when I come over to a shape like this, it kind of looks a little bit funny. So it's a parallelogram as well, right? And again, in this case, we need to figure out what they're talking about when they say base. And again, they're talking about the bottom side here. So this 2 right here is the base that they're talking about. But we run into an issue where if we tried to draw a perpendicular line and stay inside the shape, we actually don't make it to the other base. You see, so like I'm as far to the right as I can, and I'm having this issue where I can't actually measure all the way to the top like I want without going back outside the shape. So there are going to be some parallelograms where they actually extend out the base so that it's right below the top base's right-hand side or left-hand side. And you can see now I can measure this line, and that's the perpendicular. So the perpendicular didn't fit inside the shape, so we had to extend this line out. So here's where you got to be careful with this, right? This line right here, this little piece, okay, is not a part of the base measure. So I'm actually going to get rid of that color, right? It is not a part of the base measure. I'm only going to use that little 2 centimeters and then the 3.5 on the outside. So again, I'm going to come to this one and say that the area is just base times height. So I'm going to say my area in this case is 2 times 3.5, which would be 7, in this case, centimeters squared, right? And so that would be my area. So just be careful. There will be some parallelogram problems where the altitude or the height is not inside of the parallelogram. Just be careful that you don't take that little extra piece, okay? So just one reminder, okay, for triangles, that just to see one, the area is equal to 1/2 the base times the height. So in this case, again, base, I have 3 sides here. I need to determine which one I'm going to use. The base is always going to be one of the sides, like for example this one right here, okay? Not necessarily always the bottom, but it's always the one that is connected to a right angle, and in this case the 1 foot is connected to a right angle. So I'll use that as my base, and then I'm going to use the 5 inches, which comes out of that at a right angle, as my height. The only thing that I'm going to remind you about here is that when we're calculating area, we want to make sure that your units are all the same when I'm plugging in. The formulas all assume that we're using the same units. So if you notice, this one is in inches, the other 2 are in feet. So remember that this would actually be 12 inches, right? And if I needed this side, which I actually don't in this case, it's 13 inches, right? So we could turn them all into inches. So this is our 5, 12, 13 special right triangle. Remember the Pythagorean triples from back in the day, right? So I can plug in 1/2. Oh, let me fix my 1/2, okay? So 1/2, my base is actually 12, right? So times 12 times 5, right? And so you can simplify this easily without a calculator. You don't need to type that in. You're basically just going to take half of 12, which is 6, 6 times 5, which is 30. So this is 30 square inches, right? So these are pretty straightforward problems. We're really just trying to plug into the formula, make sure we identify our sides correctly, okay? So here's kind of an extension idea on these parallelogram problems. So if you remember, the formula for parallelogram we just said was that area is equal to base times height. And we can actually say that the base could be any of the sides. So here's, again, let me kind of give you an example. If I were to pick the bottom side of this one as a base, so let me highlight that for you. Okay, so if I pick this side as the base, I picked that one because there's a measurement down there. I can actually say its height would be DE right here. Okay, but the problem is I don't know the height of DE, which means if I'm plugging into the formula, I can't use that particular base and height combination. So instead, what I'm going to do is I'm going to try one of the other sides. So I'm going to come over here and I'm going to say DA is also a base. Okay, its height would be at a right angle off of that one, and this is one of those cases where I can't maybe fit the right angle inside the parallelogram, so it's actually out here. Right? So we extended DA out far enough so that when I drew it at a right angle, I would hit the edge of the opposite side. Right? So this, if you notice, I do have a base and a height. So here's the big idea. When it doesn't matter if I picked the two purple lines or the two green lines, when I multiply them together, I better get the same area, because we're still calculating this area of this parallelogram ABCD. So it doesn't matter if I multiply together DA times FC and use that base and height, or if I use AB and DE and multiply those ones together, I should get the same number. So if they ask us in this problem, what is DE to the nearest tenth, we're actually saying, you know what, I don't know, but if I know what the area of the shape is, I can figure it out, right? So if I were to use this for this green one, the DAFC, and I plug in, I'm going to say the area is equal to 13 times 9, right? So 13 times 9 looks at, don't have my calculator open. Okay, I'm going to cheat with the calculator a little bit. Okay, 13 times 9, 117. So the area of this shape is 117 inches squared. Okay. If I use now the two purple sides, okay, I'm going to do the exact same calculation again. I'm going to say the area is equal to base 9.4 times height. Well, that's DE. I don't know that one. So I'm going to call that X. Okay, so 9.4 times X. But hold on a second. Now I know the area. So I can actually get rid of this little a. We actually just figured out that the area was 117. Okay? So now if I divide both sides by 9.4 and do 117 divided by 9.4, you get a pretty long decimal, but it asks us to round to the nearest tenth. So we're going to say in this case, X, which is the length of DE, would have to be about 12.4 inches, right? And so again, this is in inches because it's just the length of a line. So if you notice, I was able to use the fact that the bases and the heights need to calculate to the same area, and I can use that to find some missing information. Okay, so there will be some of these for you to try out. Right, there'll be an example like this. Okay, so we're going to move on, and we're going to take a look at our last little piece of information is so what's called finding the area of irregular shapes. Okay, so finding the area of irregular shapes is just if this ever happens, if you get one of these and you're like, I don't know how to find the area of this picture, we can actually break it up into smaller components that we do know how to find the area of. In this case, I see a triangle on the top. Okay, so let me grab my highlighter tool again so we can kind of break this apart. So I see this triangle. Okay, which if I know the base and the height, I can figure that out. And then on the bottom, it looks like I have a square, right? Which again, that's a type of parallelogram, which we know the formula for that, 1/2 base times height. So if I focus on those and I find the area of those separately, I can then just add together the two areas, and I'm done. So what we're going to do is we're going to say the area of the triangle plus the area, used a triangle instead of an A. Let's do that again. The area of the triangle plus the area of the square is going to be the total area, right? Area, I'll put a little total down here so we know that, okay? So in this case, to find the area of the triangle, we're going to do 1/2 base times height, which for us, the base is 6 because it's part of the square as well, right? And the height they gave us is 8, okay? And I'm going to add to get to that the area of the square, which is, remember, all of these are 6, so it's 6 times 6, okay? So that's going to be the area of total. Okay, remember this entire big shape. Okay, so this looks like, again, 1/2 of 6 is 3. 3 times 8 is 24, and then 6 times 6 is 36. Okay, so that's the area of total. All right, and then I can finish this up by saying, okay, that looks like if I add these together, that I get a 58. And remember, this is the area measurement, so it's going to be inches squared, and that would be the area of the total figure, the entire big shape, right? So we have these examples where we're talking about these irregular looking shapes, right? And we can use that to figure out the answer. So here's one last little problem, okay, for us to work on. Again, another irregular shape, and I see the same kind of situation here. I have what looks like a square, and it looks like I have a triangle over here, right? So we're going to do the same kind of thing. The square, we can just say 8 times 8 is 64 in this little space, right? This is also 8, right? So this little piece right here is 8. That's going to be important because it's also the height of my triangle, right? And then this 14 at the top, I can break it into components of 8 and 6. Because 8 plus 6 gives me the 14, and I know this piece right here is 8, and I know it's 8 because it's part of the square, right? So if I do this now, I can say that the area of the total shape is going to be equal to, it looks like in this case, 8 times 8, which is the area of the square, plus 1/2 of 6 times 8, okay? So in this case, it looks like 64 plus 24, and that's going to make the entire shape look like it's about 92 centimeters squared, right? So here's one last example following along with our last one where we found out the area of the total shape by figuring out the area of smaller pieces that we know the formulas for and then just adding the answers together.